Hi everyone, this video is meant to take you through a brief example of what a permutation and combination are, how to approach them by hand, and how to use technology. The reason why I created this video was because you do have a few questions, specifically questions 5 and 6 on the Chapter 4 quiz, that are bonus questions, but just in case you want to attempt them, I figured that I would give you a little bit more information than what is available to you in the book. Also, I did notice that the technology component is not included in the text, so I wanted to make you aware of that as well. So the first thing that we're going to take a look at is going to be the permutation. So permutations are basically looking at how many different ways you can order objects uniquely. So in other words, order is going to matter. So for example, let's say we're looking at M&Ms, and we're saying that on the first try, you get a red M&M. On the second try, you get a green M&M. And then on the third try, you get a blue M&M. Again, we're talking about order mattering. So if, for example, you went through that selection process again, and this time you got a green M&M on the first try, a blue M&M on the second try, and a red M&M on the third try, this is different than the selection above. Notice that the order is different. And when we say order matters, we're basically saying we're looking for all the unique combinations. Okay. More than likely, examples that you'll see will usually have some kind of role attached to it. So the example that we'll take a look at in your textbook talks about filling roles for president, vice president, and then they have a combined job description of secretary/treasurer. So you can imagine that depending on who gets into each office carries its own different level of power and responsibility. So they're unique positions. Before we actually get into that, let's talk about the formula. So a couple things to note here. So you have P for permutation. N is referring to the sample size. And this is kind of a universal notation that we've used in the past and that we will continue to use throughout this textbook. The R in this case is going to be the number of, say, roles or choices, depending on the context of the problem that you're working with. Now, what we have here is n factorial. So when you see this exclamation point, it stands for factorial. So the natural question is, well, what is factorial, or what does factorial do? Factorial is referring to a multiplication. So it's a notation. So for example, if you have 5 factorial, this is going to be 5 times 4 times 3 times 2 times 1. Essentially, you're counting all the way down to 1, and you're multiplying each number as you go. So let's take a look at the example in your textbook. And if you need to, feel free to pause the video to grab your textbook or a notebook. I am going to clear my screen as well, or else it's going to get super cluttered. Okay, so coming down to here, we have an example that's been provided for us, and we're basically saying we are trying to fill 3 roles. The first role being president, the second one vice president, and then the third one a combined secretary-treasurer role. We have a sample size of 15 here. So this is what is ending up happening in terms of the setup. So we see that our sample size has changed to 15. And we're using 3 here because that's describing the number of roles that we are trying to fill. So this ends up giving us 15 factorial all over the quantity. So quantity is referring to the parentheses here, 15 minus 3 factorial. So the first thing that we can go ahead and do is we can take care of the subtraction. So that's what they did. So they did 15 minus 3, and that gave us 12 factorial. Now, this is where the details stop, and I think that this is not helpful. So let's go ahead and spend a little bit more time with this. So 15 factorial, this is going to be 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm sure that everyone was riveted by all of that writing. So we got our division bar, and then we're going to go ahead and move into the 12 factorial. Now, I'm intentionally putting the 12, I'm lining my numbers up with the ones in the numerator. You do not have to do this. I'm choosing to. And you'll see why, and maybe kind of get the idea as why I prefer to do it this way. But again, it's just a choice. So what I want to call out is that the top is just one big multiplication. The bottom is also its own one big multiplication. There's no addition or subtraction. So because of this, we can go through and we can actually reduce things out. So I have a 12 in the numerator and a 12 in the denominator. They're gone. As with the 11, 10, 9, I think you get the picture. You don't need me to count down a second time. So the only numbers that are left are the 15, the 14, and the 13. If we do this multiplication, we do get that solution of there are 2,730 different ways to pick from 15 people to fill the 3 roles of president, vice president, and secretary/treasurer. So maybe you're like, oh my gosh, I'm not sure if I'm feeling comfortable doing this by hand. Is there a way that I can do it by hand, but then use technology to check? And the answer is yes. So let's go to our calculator. So if you need to, please feel free to pause the video and grab your calculator. I'm going to come over to mine. Okay, and I'm also going to clean up my screen here. So I'm going to leave my answer over there in purple, but everything else can go. So if we are going to do a permutation, the first thing that you want to do is enter 15 on your home screen. So in order to get the permutation, here's how you navigate your calculator. You're going to go to the math key, which is located underneath the alpha key on the left side of your keypad. We're going to press math. And we are then going to arrow over to probability. Older versions of the calculator will probably say PRB. So looking at the screen, you can probably see the permutation notation. That's going to be option 2. So you could either press 2 on your keypad, or you could bold the option and then hit enter. This is a newer version of the TI calculator, so it automatically drops the 15 in where the sample size should be, and we can type the 3 in for how many positions we're trying to fill. If you have an older version, essentially yours is going to look like it'll say 15, and then you'll see the NPR on your screen. So the 15 connects to the N, and then you would have to type a 3 to essentially connect it to the R. Once you're done, we hit enter. And there's our 2,730. Let's go ahead and move into combination next. I'm going to clear my screens. And I'm also going to go back to our textbook. So combinations are slightly different in the sense that they don't care about order. So if we go back to the M&M's example, we could say pulling a red, pulling a green, and pulling a blue is exactly the same thing as pulling a blue, pulling a red, pulling a green is the exact same thing as pulling a red, pulling a blue, pulling a green. They're the same collection. They're made up of the same colors. The order doesn't matter. So really all 3 of these actually kind of would roll up into one option. So this is what causes the combination formula to be different. Notice here, instead of going from P to C, I mean, hopefully that part is kind of intuitive. P for permutation, C for combination. We add an extra piece here, and we include this R factorial. And essentially what this does is it removes duplicates. I apologize for the sloppy handwriting. I swear my handwriting is nicer. It's just weird writing on a tablet and then watching it on the screen. So other than that, the formula is essentially the same. So let's go down to the example that's been provided for us in the textbook. I'm going to go ahead and clear my screen. So this time they're asking us to pick 7 people out of 20 to take part in a survey. So in this situation, we can assume or we can claim that this is a combination because if you're taking a survey, you're all doing the same thing. No one has more power over another. No one has more responsibilities. They're all answering the same questions, everything like that. So when they set this up, again, our sample size is 20. And then we're only picking 7 people for this role. So we have 7 choices or 7 roles to fill. So when we set this up, we have 20 factorial, I swear I can read, divided by 7 factorial times the quantity of 720 minus 7 factorial. Sorry, everyone, it's Friday and apparently I'm running low on energy. So we can clean this up. Specifically, we can go ahead and take care of the subtraction within the parentheses. So this gives us 20 factorial all over 7 factorial times 13 factorial. The main thing that I want to point out right now is do not do 7 factorial times 13 factorial. You want to keep them separate. Multiplying the 2 factorials just as you see them is not going to give you the equivalency of what it should be. So leave those separate as you see them on the screen. So we are going to go ahead and now expand these out, knowing what we know about factorials. And I'm actually going to scoot this down because I have a lot more negative space to work with here. So 20 factorial. This is going to be 20 times 19 times 18. I don't think you all need to hear me count down again, but just follow along. Okay, so we are going to go ahead and expand out the 7 factorial, and we're going to expand out the 13 factorial. So we've got 7 times 6 times 5 times 4 times 3 times 2 times 1. Sorry, it's just inevitable that I'm going to count down. And then the 13, then 12, and so on. Now we can do the fun part and we can begin reducing things out. So I see 13, 13, 12, 12. And again, I'm able to do this cancellation because it's just multiplication. If we had addition or subtraction running through here too, we'd be out of luck. So I'm just going to go ahead and take care of those first. There's something very satisfying about being able to cancel out those numbers. And really, to kind of clean up my workspace here, because I've got the technology, I'm just going to get rid of these numbers. I'm just going to make them vanish. And hopefully not my division bar. Or actually, I'll rewrite my division bar too. That's too long. Okay. So we can continue to reduce from here. So for example, I have a 7. That 7 can reduce with 14. 14 divided by 7 would leave me with 2. 6 could divide with 18. 18 divided by 6 gives me 3. 5 could divide with, say, 15. 15 divided by 5 would give me 3. 4, I'm going to choose to have it divide with 16. We actually have a couple of options here. Just like with 5, we could have divided the 16 by 4, or we could have divided the 20 by 4, but we only want to pick one here. So that would leave me with a 4. And the 3, I can see, I kind of have my pick. I'm just going to get rid of that 3. I'm just choosing 2. The 2, likewise, I see a 2, so I'm just going to get rid of it and make it easier on myself. The 1, essentially you're dividing by 1 at this point, so you can just kind of ignore him. But now we just want to lay out what we have left. So we have a 20, we have 19, we have 17, we have 4, and we have 3. If we multiply 20 times 19 times 17 times 4 times 3, we would get that 77,520. The main thing that I would caution you about when you are doing this by hand is just keep your workspace clean. Maybe write this out a few times after you're doing your cancellations. The common error that I've seen in the past is sometimes numbers get left behind. So if you're like, cool, I want to know about the technology component, then say no more. Let's go over to the calculator. I am going to go ahead and clear all of this out. So with your calculator, it's going to be a very similar process. So we are going to go ahead and type in our 21st, so our sample size that we were working with. And then we are going to go back to math. Arrow over to probability. And we can see that option 3 is where we see the combination notation. We'll either press 3 on our keypad or hit enter. And then we will put in the 7 rows that we want to fill. And when we hit enter, we get our 77,520. I hope that this video was helpful, and I hope that it at least helps you feel like you have a good idea of how to start those bonus questions on the quiz. And if you have additional questions, feel free to email or reach out. Thank you.